Welcome students. In the previous video, we have understood how to find the equation of the pair of lines if individual lines are given to you. And we have seen that the equation of a pair of lines, the general equation of a pair of lines is a general quadratic in x and y. That is, you have an x square term, you have an xy term, you have a y square term, you have an x term, you have a y term, and you have a constant term is equal to 0. So you have some coefficients correspond to each of these terms. So let us assume that the coefficients are ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So this is the general equation of the pair of lines. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So you might be wondering why I am assuming this coefficients as 2h, 2g and 2f. So you'll understand it later. If you assume this as 2h, it leads to certain simplifications when you derive the further formula. So for now, assume that the coefficient of xy as 2h, the coefficient of x as 2g, the coefficient of y as 2f. So the general equation of the pair of lines looks like ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. For example, if you take the equation of this form, 2x square minus xy minus y square plus 9x minus 3y plus 10 is equal to 0. Now, the question that we are going to deal in this video is how to factorize this combined equation into two separate linear equations. So what is this pair of lines made of? What are the individual equations? So how do we factorize the combined equation of pair of lines? So let us see the method by which we can do that. So the method involves solving a quadratic. So you know how to solve a quadratic. So we try to convert this into a quadratic in one of the variables. So let us take x and let us convert this into a quadratic in x and solve for x. So how I do it is, you have 2x square and you can see that you have x in both these terms. So I'll take x as common from this. So plus x times 9 minus y, that is plus 9x minus xy. So 2x square, this term has been written. I'll combine these two terms. So x times 9 minus y plus minus y square minus 3y plus 10 is equal to 0. So now this equation looks like a quadratic in x whose coefficients are in terms of y. Now what is x? X is equal to the solution of quadratic minus b minus of 9 minus y plus minus root of b square minus 4ac 9 minus y whole square minus 4 into 2 8 times minus y square minus 3y plus 10 by 2a is 4. So now all these terms, both these terms are straightforward. So here we have to concentrate on this term because this term is inside the square root. So if you have to get x is equal to some nice linear in terms of y, this has to be a perfect square. I am worried now. Is this a perfect square? So let us see. I am trying to analyze the expression inside the square root. So you have 81 plus y square minus 18y plus 8y square plus 24y minus 80, that is equal to 9y square minus 18y plus 24y is plus 6y. 81 minus 80 is plus 1. So by chance, is this a perfect square? This looks so. This can be written as 3y plus 1 whole square. Right? 3y plus 1 whole square is 9y square plus 1 plus 2ab term is 6y. Luckily, this term has turned out to be a perfect square. So root of this is equal to root of this is equal to root of this is equal to 3y plus 1. So this implies x is equal to minus 9 plus y plus or minus of 3y plus 1 by 4. 4 goes here. 4x is equal to this. So if you take plus, 4x is equal to take plus, you get 4y minus 9 plus 1 is minus 8. Or 4x is equal to, so if you take a minus, y minus 3y is minus 2y, minus 9 minus 1 is minus 10. So if you cut a 4, you get x is equal to y minus 2, or if you cut a 2, 2x is equal to minus y minus 5. So these are the two lines that make this pair of lines. So let me write it nicely. X minus y plus 2 is equal to 0 and 2x plus y plus 5 is equal to 0. So these are the two lines that make up this pair of lines. So I hope you have understood how to factorize a general equation into two straight lines. So you just consider the given equation as a quadratic in one of the variable, write the quadratic formula, simplify the square root. If the square root turns out to be a perfect square, then only you can split them into two factors. Luckily that has happened here and you got both the lines. So if this is not a perfect square, you cannot find x as a linear of y. That means this will not be a pair of lines. This is a very important point. It means that not all equations of this form represent pair of lines. The equation of pair of lines will be of this form, but if you write any equation of this form, it need not represent pair of lines. We may not be able to factorize the equation into two linear equations. So now this makes us think about the question, what is the condition for an expression for a combined equation to be able to be split into two linear factors? So what is the condition which ensures that a general quadratic equation in two variables is a pair of lines? That will be the topic that we are going to deal in the next video. Thank you.